All right, hopefully everybody could see that, and we are recording. I'm in a unique position this week because I get to introduce myself. So I'm going to be giving an update on the data movement workshop and data movement exposition now that we're about 6 months in. And I'm also in a unique position where I can't see if anybody asks a question, so I will have to bank up any questions that get asked in the chat until the very end. But certainly don't let that stop you from asking, so just pump them into the chat room and I'll deal with them all at the end. I am Jason Zurawski from ESnet and Lawrence Berkeley National Lab, and I'm representing EPOC and ESnet for this talk. So this is what I'm going to go over, sort of why are we doing this, why does it matter, what it is, how we're doing it, and sort of where we are, especially with the changes in the past couple of days and weeks in the world, and why this is even more important than it ever was before. And then hopefully motivate some people to get involved and be a part of the next couple of steps that we're going to do with this effort. So to motivate a little bit of what this is, this came out of observations that we've been making within the community for the past couple of years here. And you know, first and foremost, the CCSTAR program has been very transformative in making sure that we have technology support for the basic sciences at the campuses around the country. And, you know, it's a very colorful and very useful map if we take a look at it, the one that Kevin usually presents at some of the community events. You know, 250 awards across almost every single state and jurisdiction at this point. 7 years total for this program, and hopefully going into the next couple of years as well. Millions of dollars invested, and lots of campus upgrades that were all a part of this. And even a pandemic can't stop this. I know that there's virtual panels that are going on right now to sort of deal with the next round of funding. But at the end of the day, I'm always left with the question, what does this do? Building CI is certainly, you know, something that it is physically doing, but what are we doing with that cyber infrastructure? How is it being integrated into the end users, and how are we able to sort of use this to our advantage? The goal really should be to be able to measure those scientific outcomes in some measurable way, but how are we doing that? How are we evaluating this? You know, the other thing that I'm always left wondering, especially as we talk with people and try to help them get onboarded to this sort of project, is did it all work as expected, and are we all satisfied? And all in this case really has to mean the researchers, the people who are using this infrastructure, not necessarily the IT organization. You know, how do you know when you're done is always a question that you must ask in almost any project, even if you may never really be done with something. There has to be a way to measure and sort of build upon these improvements that you're trying to make. So the reality and expectation check here is that, you know, building CI just for the sake of spending the money and doing the upgrades really isn't the right way to approach this problem. I mean, it's certainly fun to go out and to spec new hardware and software and ways to try to use it, but you have to have an end goal, and the end goal should be trying to integrate this into the users. And everybody's going to mess something up at least once. Every single group that we talk to, you know, your expectation and your reality are going to differ in some key way, and that's okay. There shouldn't be any shame in that. You know, building this up and tearing it down again to try to deal with how somebody visualizes how they're supposed to use this infrastructure is a part of the game, and that's going to make the end solution stronger at the end of the day. And it is not a success until the researchers are able to routinely and regularly use this to do their process of science. You know, is this what you want, and is this useful? That should be the first question that you're asking, hopefully during the proposal stage, if not when you first get the money and you're starting to spec this out. Because if it's not going to be useful and people aren't going to use it, then why are you doing it? In the grand scheme of things, the technology is really fun and really simple for a lot of us, right? You know, here is the classic science DMZ triumvirate here of things that you need to worry about. You know, building your network and having the data transfer capability, having performance and tests. But often the thing that is neglected and not really built into these grants by themselves is the engagement. It's talking to the people, figuring out what trainings they need, figuring out how they're going to try to integrate this into their workflows and their workloads. Because once you understand how somebody tries to interact with this system, that's when you start to figure out if it is or is not working for them. And here's the old classic example of IPerf figuring out that you have a bottleneck, a bandwidth bottleneck somewhere in your network. And yes, this just is numbers and letters that we're all looking at the screen right now, but what is it really telling us? It's telling us that, yes, when I try to run a big data transfer, probably from my DTN, or in this case, a Personar node, and I'm trying to go on an end-to-end basis, I've spent all this money upgrading my local infrastructure, but now I can't get it to my collaborator because the bandwidth is just not there. There's not enough capability in this path to be able to solve this problem. And we always trot this example out because it's very indicative of what's going on here, is that if you make these local changes and we upgrade our local infrastructures to be able to handle this, that is great, and that's the first step of the problem. But unless we understand what lives out in the great beyond scary internet, we may not be able to get that full expectation of what we're hoping to do with these use cases on the network. And what this is illustrating is that whenever we have tiny bits of packet loss somewhere out there, it's going to cause problems for this core idea of trying to move the data on an end-to-end basis. So where do we go from here? And using the old quote of the best laid schemes of mice and men, is that we need to, as a community, come back to what the core idea really needs to be here. And the core idea should be handling data. It should be envisioning a data-centric architecture for our networks. We don't necessarily need to be thinking about this from a technology-centric view. We need to be thinking about how people are physically using this information, what research they're attempting to do with it, and trying to alleviate these areas of bottlenecks and friction that are being caused because the underlying substrate is not ready to do what they're trying to do. And why this, why now? Because if we're not doing this core mission well, then we're not serving our scientific constituencies as best as we possibly can. And to be clear, there's lots of things that we need to care about in the whole CI scheme of things. And here's a partial list. I'm sure I've missed some. But for the most part, we need to be caring about the problem that is always the same at the end of the day. How do I move my data set here? Or how do I retrieve what I want to do so that I can do it locally, or so that I can some remote location where I have additional capabilities? So if we always come back to this core problem that's existed for numerous years, why don't we address what that core problem is, so that hopefully it isn't a core problem anymore? And excuses or things that we've heard from people in the past is that we need, this is really hard to do at the end of the day. Going in and talking to people to figure out what they want, yeah, it takes time. Consensus isn't easy. Frustration really abounds here. Researchers may not know exactly what they want, but at the end of the day, it almost always revolves around the data. And it's help in moving it, it's help in understanding where it exists, where it needs to come from, and ways to support it once it comes into our campus environments. And all of this really is an investment in the future. This is something that you're going to end up selling to new faculty. This is something that you're going to be selling to the VPR's office. It's a capability. It's a very important thing to have available, because almost all of these different scientific and research disciplines are going to be using this in some way, shape, or form. We, as a community, have lots of smart people here, and we're always willing to help. People ask questions on the mailing list, and I think that that's a great first start. Time is our most valuable commodity. We need to be able to spend this as wisely as we possibly can. And as we collectively come to solutions on how to handle this data architecture, I think that it's going to raise all boats, and we'll be able to really make these justifications and these investments make a lot of sense for the people who are going to use them at the end of the day. So a lot of this comes from observations that Eli made a couple of years ago, and I think it should be 3 years ago instead of 2 years ago, because the project started in approximately 2016. But what we started noticing is that scientists, use data sets. That should not be a shock, but their expectations about how long it should take and how well it should operate vary greatly. So we started this little experiment where, we were using a data portal at UCAR and measuring the speeds of the transfers as we went to the different computing centers. And the initial observations were good. Several large data sets, lots and lots of files. Pretty good performance as we went to each of these. Why can't we get this performance when we go to the greater world and the campuses that are out there? The scientist really sees their world their data world through the application, right? The way that they view things is by typing on their computer and interacting with a portal or a data transfer tool or some form of analysis. They don't really care about the underlying stuff. They don't care about which switches are there and which servers are there to support all these things. So really, we need to build all that layer so that they can build their stuff on top of it, and then it's all going to work very, very well. And that's easier said than done. We want to build on top of that Science DMZ model. All of those CI investments that we're making on a campus by campus basis really form that substrate. But now we need to evaluate the stuff that's on top of it. Is it using it correctly? Is it performing how we think it should be performing? And what does that mean? It means measuring it. And this is easier said than done too. It's the sort of thing that we need to do regular testing, regular evaluation, and regular monitoring to make sure that all this stuff is going to be working as well as it possibly should be. So the goal of this project that we did approximately 2 to 3 years ago was we wanted to have a performance goal of about 15 gigabits per second, about a petabyte a week if it was run flat out, and make sure that the tools that the users are going to be using, these portals and the underlying data movement tools themselves, were functioning at peak efficiency here. Doing that with this initial data set and doing the first couple of tests here, we didn't quite get up to those levels, but this was expected, right? Only when you do a live fire exercise like this will you see that the performance is not up to the level that you are expecting it to be. And in this case, it wasn't bad. We're still getting multiple gigabits per second in all of these different directions here, but it could be a lot better, especially when we're considering the fact that there are 100 plus gigabit per second networks that are connecting all these sites. The end hosts are, in some cases, 40 or pools of 10 gigabit servers that are linked together. And all of these are backed up to high-speed data systems that can handle the reading and the writing at a pretty good clip. So after careful tuning, and you'll notice that the initial date here is March of 2016 when we did the first set of tests here. Almost a full 2 years later, we got back to it in November of 2017. These are the improvements that we were able to sort of pull out of this infrastructure. And there's a lot of different things that had to go into getting these numbers. It isn't just making sure that the networks are operating at peak efficiency. That's just one piece of it. It's making sure that the hosts are working at peak efficiency, all the network level tunings, all the file system tunings, the application level tunings, a lot of different stuff. But as you can see, there are ways to really get the full amount out of these different transfers here. And who does this benefit? Sure, it benefits us as network people because now we know that there's stuff that's going to be working at this capability across these networks, but it benefits the users most of all. And they're not going to necessarily notice this because, again, they're using an application that rides on top of all this stuff. But if we spend the time to do the evaluation and ensure that things are working out okay, it's one less thing that they have to worry about so that they can go about doing their research as efficiently as possible. So just to pull us back to reality here before we get into what we're trying to do with this project is that data movement really is hard to get right. There's a lot of different moving parts here, whether it be software or servers or networks, but most of all, it's the people that we have to deal with here. The testing is going to reveal things that you may not want to see and that you may not want to hear, but that's okay because it's going to motivate you to make it ideal. And once we understand what the basis is, we know how we can improve and we know how we could build upon that success to go out and fix the problems for the people who are clearly having them but may not be noticing about it. So how are we approaching this? The data mobility exhibition, it's a mouthful, is really our attempt to try to fix all these problems that the scientific community cannot do for themselves. They want it to work. At the end of the day, that's really what they want. We have a unique position in our community here because we are at computing centers and university campuses and regional networks and national networks. We know where the data repositories are, we know where the networks are, we know where the analysis and the storage happens to be, and all of us collectively own this stuff. We have the ability to run these tests and figure out if things are working or not working, and then we can go in and try to fix these problems such that it will benefit the people who are riding on top of all of this. And for people who may be curious, the name origin comes from this. You can watch the YouTube on your own. It's an old David Letterman clip from Stupid Pet Trick days. But Matsakauskas and I are very fond of saying this whenever we get into a discussion. Remember that this is only an exhibition, not a competition, so please no wagering. And there's a lot of truth in this. The effort here is more about visibility and fixing problems, not crowning a winner. We don't want this to be a quote unquote competition. We want this to be about understanding that we collectively want to get the best out of our infrastructure, and collectively we will all be able to fix these problems together. And yeah, there's certainly going to be people here who are blowing the doors off of everything. You know, they're milking every single piece of bit that they're going to get out of their giant pipes and get 99% utilization out of their file systems, and that's great. I'm more stoked about the smaller facilities as well, because those are the ones that are going to be having that functional DTN that's going to benefit that scientist. So what are we trying to do here? We're trying to get the community engaged, and we started this effort in September of last year, but now we are about 6 months in, and we want to remind people that, yeah, we're still doing this, and now it's pretty important. We want to make sure that things are functional, and hopefully we can get more people testing, and we can start evaluating what's going on and fixing these things as we go. It's more about the people aspect. This is a social. So we will be engaging with anybody who's willing to engage with us. And equally, we want people at these various facilities, once they spend the time to get the technology functional, to engage with their stakeholders. Go back to those different scientific groups, explain how this stuff works, see if there's ways that you can integrate their existing workflows to try to take advantage of it. The reality of it is really a spaghetti bowl of all kinds of different stuff that's sort of bolted together. We have our big science networks, we have our regional networks, we have agency networks, we have all this different stuff and all these different endpoints. But if we abstract that just a little bit more, what does it look like? It really is a data-centric architecture. It's a bunch of science DMZs that are connected together via that science network ecosystem, and they all have data. They have data, they have experimental capabilities, they have computational capabilities, and really we can try to bolt another layer of abstraction on top of that, is how people interact with it, whether it be an experiment or a data portal or an analysis facility, whatever it happens to be. All of these things can work seamlessly together if we go through the steps of trying to verify and validate and ensure that everything is working the way that we think that we designed it to do. So now we get to the actual ask here. What is the ask of all of you? This was meant to be a 3-part event, and we already completed 2 of the parts. It was workshops that we hosted at the previous CCSTAR PI meeting in September of last year. Now we're still in the midst of the data movement exhibition piece. We want to prove that as a community, we can improve these data movement outcomes. Who is able to attend or participate, I should say, really anybody. We were targeting CCSTAR awardees because those are the sites that have all this new infrastructure that is capable of doing this, but you don't necessarily need to be a CCSTAR awardee to participate. You could just be a large data facility. You could be a DOE lab, you can be a DOE facility, you can be involved with NOAA research. It really doesn't matter. We're happy to work with anybody here. And we want to take all of these results, and not necessarily just the raw bandwidth output of what each site is capable of doing, but the results of who participated and who spent the time to improve things, and highlight these at the next CCSTAR PI meeting in fall of this year. How do you actually accomplish this? Well, we have a bunch of reference data sets, and we're asking that everybody who wants to participate, you use an existing campus CI component. We don't want this just to be a stunt machine. We don't want this to be something that you set up specifically to compete in this little exhibition. We want this to be the thing that is hooked up to your scientists' data movement capability. It could be affiliated with physics. It could be affiliated with bioinformatics. Whatever the case may be, if this is something that your research community is using, that's the thing that you should be using to participate. Because what you're going to end up doing is downloading the reference data set. You're going to measure the results, and hopefully, if things are not working out the way that you think they should be, improve upon these. The other piece of this, beyond just performing the act of downloading and recording the results, is that if you really do want a consultation on how this is all designed and if it's working out the way that you think it should, write up a brief little description of your network and data architecture, do the actual test yourself, but then contact the EPIC group, epoc@iu.edu, and we'll set up a phone call, whether it be a one-on-one assistance where we can go over the network architecture with you, or just, helping you debug any problems that happen to come up. We've had a couple of these so far. These have been somewhat easy to solve, and others are a little bit more complicated. Some may just be helping to evaluate if there is a peering problem or a performance problem between two different sites. Others may be a little bit more complex, where they're trying to re-architect how the data movement architecture really looks and operates. We're available to help with any of those different needs. And we do want to run this through September of 2020, although there probably will be an extension into the future, since a lot of time has been lost this year. Really, we want people to test as many times as you're willing to, and then have us evaluate these things. Also, the email list is a good place to sort of share strategies and results. People are always happy to help whenever you share something on those things as well. So what's our current status with this? I'll summarize it with one of my favorite Calvin and Hobbes. I can present the material, but I can't make people care about this. The only people that are going to care about this is if you really do have a scientist that is bugging you to fix the data mobility challenges that they may have. I don't want to talk about data mobility anymore. I would hope that this would have been a solved problem years ago, but it's not necessarily a solved problem. We need to be able to approach this programmatically as a community, so that we don't have to be worrying about this wizard gap anymore. We have smart tools, we have smart networks, we have smart people. Why can't we get this stuff all working together? The big scientific communities, and big in this definition would be your LHCs and whatnot, they're making the investments into these things. The smaller ones and the medium ones, it's a little bit harder for them to do so. So really, that's sort of the groups that we're targeting as we try to get out there and fix these different things. And what does success really look like? Well, at the end of the day, it is improved scientific outcomes, which hopefully are either measurable or verifiable, but it's also happy users. And we just want this to be people who don't have to worry about the active data movement anymore. We don't want this to be the, oh, well, I had data to move, so I shipped the disk anymore. That's still occurring rather regularly. The other thing that you get out of this is it is justification for upgrades, because if you can show that people are using this infrastructure, it makes it a lot easier to go back and say, hey, I can build this a lot bigger, because more people probably will use it at the end of the day. So as of late February, we had a couple of groups that have taken the steps to do these testing. We were able to pull out about 15 or so identifiable tests and results. I think a couple more have occurred since late February, but that's the last time that we went and crunched the numbers. Basically, we're seeing a pretty good range of performance. NCAR and Petrol are performing very well to high-speed sites. Many other sites may only have a single DTN, and that's fine. There are others that really do need that performance tuning help, and we've started the process of reaching out to some of those as best as we possibly can, if we can figure out who they are. And then others have contacted us for a little bit of help as well. So we're seeing good results. We need a lot more data, and that's really what this effort should be about. It should be about getting as much information as we can about the current state, spending some time fixing it, and then we'll get to the next steps after that. In terms of our participating sites, we have both US and international that have participated so far. People from those states right there, as well as a couple of others. Almost all of these sites are already very capable, and that's good. We don't need to spend time fixing those that are working very well. We have data points, though, and we can say, hey, these sites have spent the time to make this upgrade and make these things work to their advantage. There are some that need the help, and we will spend as much time as we possibly can helping those people. There is clear value in this participation, though, so if you represent a large university or a regional network or a national network, please encourage people to make the step to try the test, because this will benefit everybody in the long run. So, as people may know, we're all under lock and key right now. I went out and pulled a couple of my favorite things that I've seen on the internet in the past couple of days. I think my favorite one there is this episode of Black Mirror sucks, because I have to admit I was thinking that as well. We're all stuck at home. We all have hopefully, things to do. But if we don't have anything to do, we can focus on this because, hey, this is a useful thing. This is at least what I've been doing with my time when I'm at home. Looking at the same four walls, you can only rearrange your house so many times. You can walk your dog, but sometimes the dog gets afraid of that. I've been playing around with NTOP-NG a little bit, which is really neat. It showed me that I have a lot of traffic on my network, as you can see from the little picture at the bottom there. But there's also lots of these COVID-19 research pleas that are going on various mailing lists, whether it be, hey, help identify computing resources or storage resources or programming resources, and that's great. I support that 100% because we want to find as many ways to deal with this as possible. I'll pull us back one step, though, and a more functional thing is to do this properly, you need working infrastructure, and that working infrastructure should have been in place already. People should not be shipping disks in this world for two reasons. Number one, shipping implies contact, and contact is a bad thing. Now it's also nobody's on campus to go and pull the disks out of the thing to go back and ship those things. So personally, I think that we need to live in a world where, hey, I can click a button and have a data transfer just work instead of me having to drive to campus, pull out a disk, and ship it in a UPS box. So what should we be doing? I think that if we have the time, we figure out how to get multiple DTNs up and running on our campuses, as well as Personar and things of that nature. You can spin these up remotely. It doesn't need to be, the big honkin' $4,000 server. It could be a VM just to start, but it should be plugged into your institutional storage. It should be accessible by your various users. Whatever the case may be, that is your conduit to the outside world. That is your data capacitor to pull in and push out and hopefully benefit these groups, whether they're working on COVID-19 research or whether they're doing something else. Whatever the case may be, the infrastructure is the first step, and then the usability follows after that. The other thing, and this is something that we've been working on a little bit within EPOC, is to get us away from that stopping of the physical shipping of disks. It's making software that rides on top of this infrastructure that is easy to use for the people who need to use it. Lots of scientific efforts have the concept of a data portal already. Genomics, climate data, sky surveys, whatever the case may be. But the portals were designed many, many, many years ago using the cutting edge technology of the day, which was usually just Apache and MySQL. How do we fix that? How do we upgrade the concept of a portal so that it performs well with these new technology investments that we've made? So here's your basic schematic of what a portal may look like. Sort of a single armed thing that is a server that has a window into the data, and it handles all the different functionality of search and database and authentication and data service and all this different stuff. But really what we want to be able to get away from is having all of that be served by that same arm. We want to be able to separate out the data channel and the control channels like we've done with other designs that we've done within our community here. So instead of it looking a little bit like this, it looks a little bit like this, where we have the data transfer nodes as the vessel for moving the information in and out. We still allow the portal server to be a portal server, but the data is able to sort of function on that fast path that we've invested in. And that's what I just basically said. So the data handling is separate and scalable. You're able to sort of outsource the idea of the data handling to computer centers and then allow them to deal with the orchestration of data placement. Why should we care about this? Well, first and foremost, you're going to get your performance improvements when you do this, because if you're relying on the old technology to do the data transfer from your portals, you're going to be stuck at HTTP speeds. If you're using a better tool under the hood to mitigate the act of moving information on an end-to-end basis, it's going to work at that tool speed, which is usually much better than what HTTP can deliver. This is also sort of the next stage in support, because these different groups do not have the cycles or the manpower to redesign these things on their own. A lot of the data in their field is behind these legacy portals. So if we're able to go in and install a better functionality, this is going to be of immediate use to a lot of these different groups. So what are the next steps for us as a community here? The main idea here is that we do want people to participate in the DME. We have a website that's available right there. If you don't want to read a web page, just shoot us an email. Either Epic or Ken Miller on my team is going to be the point person for people who want to participate in this. Either will help you with whatever you need help with. If you're interested in the last little bit of what I talked about, the portals, Epic is piloting a very, very early portal idea here. And, you can interpret that as, oh, it's beta. It's only been tested on 1 or 2 sites. But if you are willing to work with us and you have a researcher that needs a data portal to support sending or receiving information from collaborators, this may be something you want to look into. Shoot me an email or shoot Epic an email and say, hey, I want to talk about your portal idea, and we're certainly happy to help you with that. And lastly, if you just need to consult on any other topic, whether it be DTNs or DMZs or firewalls, or you're just bored and you want to talk about your dog, that's fine. We've been doing calls every day, all day, with people who are coming back to these projects now that they have some free time on their hands. So if you do need a consultation for whatever you're going to be doing with your campus technology in the next couple of weeks or months, however long you're stuck inside, let us know. We're happy to help with that. So I will now open up the floor for questions, and I know that a couple of chat items came in, so I need to stop my share so that I could see that. All right, so the first question that came in was from Hans. What is one big example of an issue you have run into over the last 6 months of doing the DME? I'll give 2 examples. I think the first one that we've had was somebody who ran the initial tests and sent in the results and said these are a lot lower than what I would expect them to be, and they were in the low megabits per second. Once we figured out that they were dealing with low megabits per second, we asked them, all right, can you provide us, the basic things that we would need to do troubleshooting, per sonar node instance, or failing that, just some trace routes and performance test results that you may have run yourself, and they gave us both. We were able to look at the per sonar node, and we were able to do some routing deep dive to figure out what was going on there, and lo and behold, we figured out that there was a long-standing routing problem. Instead of going over research networks to get between the source and the destination of their data movement, they were going over commercial networks. And usually when you're able to point that out and tell somebody, hey, this is something that needs to be solved, it gets fixed. And in this case, it got fixed a little bit slower than maybe everybody would have liked, but the routing was normalized, and then we did R&E networks for both sides of the transfer. And even then, performance went up a little bit, but it didn't go up all the way. And then this led us to fix some of the other things that were wrong, tuning on the host, and some problems with the data access itself on the local side. The writing wasn't as fast as it probably should have been. So that was sort of one example. Another example was just somebody not having things configured. They couldn't get the stuff working. And this all comes down to pretty simple things to work with on the tool end, figuring out permissions are correct, and making sure that it's able to sort of interact with the underlying data and all those other good things. So that one wasn't very hard. It's just a matter of making sure that the tool was functioning properly. But I think that those are 2 very indicative problems that we were expecting to find as people went about this. So we're certainly hoping that more people will run the tests and get in contact with us. So if anybody is experiencing problems so far, certainly let us know. And the second question that I see in the chat room is from Bill. What would be a good set of tests to focus on? Only DME read endpoints to your network and your network to all DME write endpoints, or from DME read endpoints to other DME write endpoints too? I think both are really good answers, Bill. It's easiest to do sort of the download test first. And in many cases, that's sort of what a scientist is going to be doing in their use case, right? They're going to be accessing some data that's remote. So they're going to be downloading from the remote location to the local campus, and then doing something with it. And then, subsequently, they may upload results to some other location. So I would say the first step should be focusing on the download side. And then if you're satisfied with what the results are with there, you can then move on to sort of doing the write to the external things. One thing I should note, and maybe it didn't come across in the talk, so it's worth repeating, is that the DME endpoints that we've identified for the testing should be well tuned and working well. Things always happen though, so it may be the case that you get some weird test results and you want to verify them with us. Certainly let us know. We'll make sure that both ends are working as they probably should to help normalize and fix any problems that come about. And the third question that I see is from Kurt. DME is using optimized data sources and testing the download path to the science edge. The common problems we see after getting DTNs functioning on our local campus is data sources not well designed. Do you envision a DME2 to measure this problem? Absolutely. Once we identify the edge-to-edge problems, so to speak, we're going to get into the deeper, where does the data live on campus? How is it plumbed? All those different things. So I think at least to first order for this first round of this exercise, we will focus just on the low-hanging fruit. And I won't call it easy because none of this stuff is really that easy. We'll focus on that first, and then we'll sort of get into the how is this integrated into the scientific workflows piece. So I'll just pause right there to take a drink, and then if anybody else has other questions they want to type into the chat room, do so.
Can I talk you into taking an audio question?
Certainly, as long as you don't have a barking dog in the background.
No, not this time. So what's been your success rate with, as you've helped institutions basically achieve their data movement goals, those lessons that they've learned from you guys kind of sticking? Or in other words, you've gotten this project sorted out, data's moving better, they're happy with the results, but then 2 years later, they're doing another project. Are they typically learning and adjusting their networks based on what they've learned from you in terms of tuning for high speed, or are they just basically repeating the same types of mistakes in the future and need intervention again? I'm just kind of curious what the long-term success rate has been.
Yeah, great question, and certainly a hard one. I'll hedge and say it depends. I think that as long as there is a quote-unquote champion that exists on these campuses, they're able to replicate the lessons into other local use cases and sort of keep the train going, so to speak. The problems that we run into is that if we do an engagement with somebody and they install it and it's working well for some short period of time, eventually that person is going to age out, whether it be from retirement or changing jobs or whatever the case may be. And often the lessons are not translated into the next generation that comes in, which is a shame. So, it all goes down to once we work with a group, we want to document as best as we possibly can so that people understand how the process is supposed to work, and then they can hopefully continue to replicate it and maintain it going forward. There's only been a couple of instances where we've had to go back and sort of re-architect things. Most of the time, the use cases are similar enough that they can replicate them on their own and not be able to lose some of the benefits that they've gained. And I see that somebody put a snarky comment in the chat room. Looking at you, Deaton. Eli also adds another perspective here. It's hugely valuable to put DTNs in front of the storage for campus clusters. And he's absolutely right, because the storage for campus is where the science lives, whether it be from the agronomy department, the chemistry department, or from the performing arts department. If you can put the data transfer capability in front of where the stuff lives, it benefits all the users. If you put it in somebody's lab under their desk, it only benefits that person. So food for thought. I'll give another pause here in case anybody wants to type in or ask any other questions. All right, well, seems like we may be at the end of our questions, but certainly this is not the end of the conversation here. Let me go back to the slides really quick just to put up the email addresses in case people didn't see them. So those are the email addresses that you can leverage if you do have questions about the DME itself, Epic or Ken. And if you want to talk about portals, you can email me. And if you just want to start a consultation, you can email me or Epic as well. So hopefully everybody is staying healthy. We will have another talk next week. It's going to be Eric Boyd from University of Michigan, and he's going to be talking about their CCSTAR project to implement a network security infrastructure for the entire campus there. So hopefully everybody can make that. Otherwise, it'll be taped. Please have a good weekend, and we'll talk to everybody soon.